All right, so we're going to begin today with finishing our fraction skills where we left off with prime versus composite, applying that to our finding the common denominator, and then I want to address problem areas and so forth with fraction math skills, making sure that your fraction math skills are up to par for intermediate level, even up through 8th grade. So let's go back to prime and composite, and again we are dealing with kind of in primary math that in the next hour, where our theme the last couple of days and again today is the idea of teaching from scratch. Okay, because they have to begin with place value, they have to begin with just the bare bones of how to add, how to subtract, then the carrying and the borrowing. But I want for you to think kind of as a theme for this class, we're doing a lot of expansion, aren't we? And we have more procedure. And I'm not saying that we ignore the concept step of our 7 steps, but what I am saying is we're doing a lot of expansion. And so I want our theme, well, can any of you guess what I want our theme to be? One of you even did a bulletin board on it. Nobody knows? Let me jog your memory. What about, we talked about reducing. And now we're going to be talking about finding the common denominator. What's the theme? Come on, guys. Go ahead, take a stab, Rebecca.
Well,
we're talking about procedure and expansion. And once we get into 5th grade, 6th grade, 7th and 8th grade, for sure, we need more what? Tools in the toolbox. So I'm not thinking about a particular concept, I'm thinking about a theme. So as we go through intermediate math, yes, we are going to review and kind of solidify your math skills. So I'm going to be doing more math review in here than I did in elementary. But I want, as a theme, my primary students, I want them to think I'm teaching from scratch. I have to reach their understanding. I'm spending more time on concept, less time on procedure. And for intermediate class, I want you to think I'm doing almost the exact opposite. Hopefully a lot of the concepts are already there. Yes, I'm going back and solidifying concept, not so much teaching it, but I want you to think I'm doing a lot of procedures. I'm doing larger problems. I'm doing long column addition. I'm doing division with maybe even up to a 3-digit divisor. I'm bringing in the decimal point. I want you to think that you're going to provide your students with more, here's our theme, tools in their toolbox. Okay? What are the 3 tools that you want to provide them in their toolbox that they can pull out when they are reducing fractions that are too big for their times tables? What are our 3 reducing tools? Rebecca can give me one. The divisibility rules. Another one.
Prime factoring.
The prime factoring and cancellation, yes. And that's the first tool. Their first tool is the one that they use in 3rd grade and 4th grade. Well, not so much 3rd grade, in 4th grade and even 5th grade. But once we get into 6th grade, 7th grade, and 8th grade, we need a power tool so that our students aren't doing all this random trial and error division. So yes, we want the divisibility rules. Yes, we're going to use our times tables, but we also now are going to think, okay, I'm teaching 7th grade. Next year, they're going to be in pre-algebra. Next year, after that, they're going to be in Algebra 1. So I'm giving them more tools in their toolbox so they can quickly reduce a rather messy fraction. Now, the other thing we're doing today is we're going to have more tools in our toolbox with respect to finding a common denominator. Okay? And that prime factoring technique that I'm showing you for our 3rd tool in our toolbox for finding common denominator is based on prime versus composite. Students, many students, even high school students, do not understand the importance of a composite number. We learn in 4th grade prime numbers, and we learn what composite numbers are, and then we kind of don't use them, we kind of set them aside. Well, now it's time to realize what a composite number is and use it to help me find the common denominator between numbers that are above my times tables range. So what are our 3 tools? What are our 3 tools in our toolbox for finding the least common denominator? The first tool, once again, the first tool is our times tables. Right? The second tool is going to be listing multiples. And many times our failure to use terminology, especially the term factor and the term multiple, is going to come back and cause our students problems when we have to do least common multiple, greatest common factor. All right, so the tools in their toolbox for finding the least common denominator begin with the times tables. Also can be used so you can list multiples, but the power tool that will help them quickly to find the common denominator when we're using numbers like 18 and 24 and starting to get larger denominators, we need a power tool. Okay, so but we're not going to be able to use our power tool if we don't have the skill to use it. Then it becomes dangerous, doesn't it? Okay, so our power tool that you want to get in their toolbox and probably in your own toolbox is the fact that we can cancel prime factors. And as students progress into pre-algebra and algebra 1, they're going to learn the exponent laws. So in algebra 1, we do not work with big numbers. We prime factor them, and then we use those bases with exponents just like we use x and y. So we need to not say, oh, why do they need to learn to prime factor? Because they're going to need to use it later. All right, so there's the tools in our toolbox. And so if we're going to use this power tool, whether it's for reducing, which they have to do in algebra 1, we start doing algebraic expressions and putting them in the numerator and in the denominator. If they're going to learn to use that power tool, they have to understand concept. So as the intermediate teacher, I am going to go back to what is a prime number, what is a composite number. Now the prime numbers are easy. A prime number is what? Any number whose only factor is 1 in itself. Composites then are all of the other numbers that are made up of repeated, not necessarily repeated, but they're made up of more than one prime factor. What about 1? 1 and 0 are 2 special numbers. What are 1 and 0? What's 1?
They're neither prime nor composite.
They're neither prime nor composite. What are they? What is 0? Do you remember? It's additive identity, right? What is 1? Multiplicative identity. So 0 and 1 are neither prime nor composite. That's because they are the additive identity number 0 and the multiplicative identity number 1. They don't count, so that we have to teach them that 1 is not prime and that 0 is neither prime nor composite either. They're special numbers. Okay? So then, prime and composite, what are our main prime numbers? And then, of course, 11, 13, maybe 17 once in a great while in 7th and 8th grade will crop up. But we're mostly going to be considering these first 4. What about 2? What about 2? 2 causes problems. 2 is the only even prime number, isn't it? So don't forget that 2 is also a prime number. And then our composites are all of the other numbers besides 0 and 1, and then the primes. So a composite number is made up of a series of prime factors. Okay? So we know that, and as college students, you know how to prime factor. You're a little more familiar with it than your intermediate students would be, but here's what you have to teach and show students is now how we're going to use composites. Okay? Let's get even bigger. And let's just play with this composite. I'm going to add 2 more 2s, and 1 more 3. Does anybody know what that number is? Well, here's a 4. Here's a 3. What's 4 times 3? 12. Here's another 4 and another 3. So that's another 12. What's 12 times 12? We can do a lot with 144 in its prime factored form. 144 is a very versatile composite number that I like to show you and look at it. We want to be able to now use the fact that 144 is 2 to the 4th power, 2 times 2 times 2 times 3 squared. So 144, you're going to find I will use a lot as a common denominator because look at all the different numbers that go into it. Okay, let me ask you, does 16 go into 144? Oh, let's find out. No. Do you see 16? I see 16 in 144. So how many times does 16 go into 144? 9. Okay, and a lot of students don't realize how this works. If I can see the factors of 16 in the prime factors of 144, I don't have to do this random division, do I? All right, so many times then when I'm trying to find the least common denominator, and what if I have 16 and 12? What if I have 16 and 9? I don't have to spend all this time randomly searching, trial and error. Trial and error is not a math skill so much, is it? Now sometimes we have to teach students and they have to do a little bit of trial and error with long division, but eventually you shouldn't have to do very little trial and error. You certainly don't need to do random division. Okay, many times I'll see quizzes with college students even that have all, when they're trying to figure something out, they've got all this random division problems all up the margin of their paper with reducing and with finding the least common denominator. So that's unnecessary if we understand what a composite number is. So I can immediately see that 16, yes, is a factor of, and I need to use the word factor, of 144. And I can even immediately see how many times 16 goes into 144. Or 16 times what factor? 16 times 9 is 144. Not a multiplication fact, is it? Okay, does 6 go into 144? That's a little easier, because obviously 6 goes into 12. But how many times does 6 go into 144? 24. See how much fun we can have with our prime factors? And then we can start using them and realizing that prime and composite is not just something that we learn in the 4th grade and we identify numbers as being prime or composite. We start using our composite numbers. And then this is 2 to the 4th times 3 squared. Then in algebra, we're going to be more familiar with that, and we're going to be able to apply the exponent laws. We can apply them to here or here. In Algebra 1, we shouldn't be working with 144. We don't do big numbers anymore. We prime factor it and use our exponent laws. Okay, so all of these things are building their math foundation so that they can succeed in 7th grade, 8th grade, and then even transition and succeed in Algebra 1. So do you see what I mean by the composite number? How many times does 4 go into 144? We're not going to do this on our scrap paper or in our margin. How many times does 4 go into 144? Well, here's 4. So 4 times 9 is 36. And I'm not going to have minor division errors that are going to throw my larger problem off if I have a way to attack a problem that has 36 in it, or has 14 in it, okay, or has 18 in it as one of the denominators. So we can always work in terms, with a larger number, we can always work with it in terms of its prime factors. So I'm going to use this idea to find my prime factors to, whoops, I wrote cancel. That's reducing. Let's use this word instead. Canceling prime factors, that's how we reduce. I was thinking of my other tool for my reducing, grouping prime factors into the least common multiple. All right, so prime and composite. Make sure students realize that a prime number, of course, is any number whose only factors are 1 in itself, and we're going to deal with these prime numbers. But even more important than that, they need to realize that a composite number is simply a multiple of primes. Okay? So 144 is a multiple of all these prime factors. And then we do not have to do all this randomness. We don't have to sit and skip number 4 because the denominators are 16 and 18. Okay? We can easily figure out the least common denominator. Oh, does 18 go into 144? Does 18 go into 144? Is 18 a factor of 144? I see 18. We got all this mess here. I'll double out, underline. I see 18 right there. How many times does 18 go into 144? 8 times. I don't know about you, but I don't usually think of 144 as being 8 times 18. Do you? So what if we have 8 and 18 as denominators? How can we apply our composites? And then this will also cut down on making a mistake when you multiply to get your new numerator. If we're thinking of this 144 as being 4 2s times 2 3s, then we're not going to make mistakes and we're not going to have to do all this scrap work in our margin or on another piece of paper. So now we're going to be grouping prime factors. This is a technique that is used to find least common multiple. This is also the technique for finding least common multiple. This is too, because remember, least common multiple is least common denominator. Least common multiple is the actual what it is. Least common denominator is how it's used. Okay? So let's now apply this to common denominator because that's what it's used for. Let's just start with, what if I had 3/8 plus 7/18? Least common denominator. Well, there's 8. Here's 18. Remember, we can always find the least common multiple by dividing the product of the two by the greatest common factor, because we do not need this 2, do we? And what we can do is we can group the factors of 8 with the factors of 18 and see we overlap at 2, don't we? What is 2? It's the greatest common factor. So we are not going to use 18 times 8, which is 144. Do we need 144? Nope, we're going to use 72. So when we are grouping our prime factors to find our least common multiple, we're always going to eliminate one of the numbers that's the greatest common factor. Do you see the overlap? So my least common multiple is 8 times 9, or 72. See how I grouped that to find my least common multiple? Because I don't need 144, I'm going to use 72. And then I can work with the smaller numbers. And then, okay, I need 72. I'm not going to have to do, 18 into 72. Well, I hope you don't have to do 8 into 72. That's the times table's correct. right, so we can be a lot more efficient. Okay? Think about you have a storm and a big part of a tree comes down in your backyard and all you have is a handsaw. You're going to be there days and days and days. What if you have a chainsaw? A whole lot easier. Little dangerous, but a whole lot if you don't know what you're doing and you're a little careless with your chainsaw. But this will be able to, if you know how to use it, you'll never struggle with finding a common denominator again. Even if I give you 18 and 8, 36 and 8. Okay? Different things like that. So, and then to keep going with this same example, when I look at things in prime factored form, I am not going to do, oh, how many times is 18 go into 72? I'm going to look. Here's 18, right? How many times does 18 go into 72? 4. So then I am going to do 7 times 4 when I raise my 18ths into 70 seconds. And of course this one's easy because it's times table range. That's going to get me into my common denominator faster and into my higher term fraction faster and a lot more accurately than doing all this little math here. Okay? I don't have to do this because I'm pretty fast at that. I'm faster with this. And so would you be. Okay? So this is a power tool that you can use. It's going to help you choose your least common denominator faster because you can see it. Can you see it with your understanding here on the board? You can see here is 8, here is 18. I can see the overlap, which is the greatest common factor, and then I can, right here in my 72, I see my 18 and I see my 8. Another way to show the overlap. And then I can do whatever I want with the 72. How many times does 3 go into 72? 6 times 4 is? Yes. How many times does, well, 8, that's pretty easy. This number is a little small. How many times does, there's 18 again. How many times does 24 go in? 3, and so forth. You can easily see very quickly and accurately, provided you prime factored properly from the very beginning. All right? So this is our power tool that we can use. And my 7th graders have to use this tool because otherwise it takes them forever to do their problems, especially on a quiz or a test. So this isn't something that only high school students do. This is something that when we're using the Bob Jones curriculum, in the Bob Jones curriculum, the 7th graders have to be at this level. They might get what I just mentioned. They might get, what is 7/8 plus 5/36? What are you going to do? Random multiplication, random division? No. And when we practice our prime fact, oh, this is something else we could do with flashcards. In our drill time in 6th grade, instead of wasting my drill time with 1 foot equals 12 inches. Now I realize that's kind of a stretch, but in a wild example because you probably wouldn't be drilling that in 6th grade anyway, but don't waste your drill time. This is something else you can do to sharpen their minds with mental math. You can hold up a flashcard with 8 on it and have them mentally prime factor it. So they're going to be really bad at that at first. But eventually they see 8, their brain's going to do 2 times 2 times 2. Okay, mine does. Why does mine do that? Because practice, 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 years and years and years. What is 36? Immediately I think 9 times 4. Well, I'm not allowed to use 9 and 4. I kind of do a factoring tree in my mind. Here's 4. Here's 9. What's my least common denominator? Well, here's an overlap. So let's put this up. I'll get rid of the wheels. Here's 8. There's 36. I see an overlap of Here's 8. Here's 36. I can easily see my common denominator is going to be 9 times 8. We're back to 72 again. Are you going to think of 72 off the top of your head? Probably not. You don't have to think of it off the top of your head. You don't have to start trying numbers. Okay, random numbers. There's nothing random about this. All right, so you can see from this, let me move this over. I can see my least common multiple. I can also see my greatest common factor. See how I wrote those so that they, with the overlap? Then on the quiz and on the test, when I ask you for least common multiple, greatest common factor, you can do it at the same time. Here is the greatest common factor, and then when I put these two together, this is the least common multiple. I don't need these 2's, do I? They're the overlap, they're common to both. And then this is a little smaller, but you can see here's 36 right here. How many times is 36 going to 72? That's easy, it's 2. So 2 times 5 is 10. And we know from our times tables that 8 times 9 is 72, so 63, and I get 73 70-seconds. Pretty easy sum, okay? So prime and composite are not just little extra frosting that we put on our cake so our students know the terminology. We will use it later. We will use it when we have to bring our arithmetic skills up into intermediate level, and we will use it in algebra. Maybe we'll replace those factors with x's and y's, but we're still doing the same basic thing. So make sure that you can find the least common multiple and the least common denominator, which is the same number. Least common multiple is what it is. It's the smallest multiple between 2 or more numbers, but then least common denominator is how it is applied, how it is used. So your fraction addition, I'm going to test you on that with larger denominators, okay? And you're going to have to apply your power tool of prime factoring to addition of fractions. All right. The next thing and the last thing I want to do before we leave fractions is deal with progression step number 6, problem areas with fraction math. One thing with problem areas that we need to do, what is the importance of this step? Problem areas, what did we say last semester about problem areas? Yes, don't ignore them. Don't ignore them. They won't go away. They'll keep cropping back up. They'll keep coming back to haunt students, and they're not only going to get worse. So the first step in dealing with problem areas is identifying them ahead of time and trying to head off the problem before it occurs. You want to head the problem off before it occurs, and to do this you have to identify it, and then you have to have a plan, and then you have to attack it. Okay, so we're going to identify, plan, and then practice. I think I've told you before that every year the same problems occur irregardless of who's in the class. Okay? Every year the same problems occur regardless of which class it is. All right, so let's first identify the problem areas, then take a couple of them and but plan, and then it has to be practiced. If this is kind of what I mean by not ignoring them. You've got to keep practicing them, and then they are no longer a problem area. What is a problem area? Remember, these are areas where two concepts can be confused, or area where a single concept has a lot of steps, and so forth. So let's start with identifying problem areas with fraction math. Okay, fraction math. What are the problem areas that you will deal with? Fraction problem areas. Who can just give me one? Think about yourself. Think about, hasn't been that long, 6th grade, 7th grade, arithmetic. What did you miss? What did you always get docked for? Anybody have one? Yes?
Not reducing.
Not reducing? Yes. Not reducing. Okay. Another one.
Confusing the grades coming back down.
Yes. That one's later. All right, so if we're not reducing, that's common. And we'll get to yours. Another one? Least common denominator. And often this problem area, what happens with this problem area is not that they use the wrong common denominator, is that they give up and go on and just miss the problem. Okay, they can't find it. And so they leave it blank. Okay, and we don't want our students to be doing that. And we don't want our students to get in the habit of, it's a hard problem, skip it. Now maybe on a test and you're short on time, you might skip problems, but not on homework. Okay, so what is the common denominator? Another one, kind of think in order. When you're first starting with fractions, you're going to forget to reduce. You're going to have trouble with common denominators. What's the next thing you're going to have trouble with in your class? Maybe not yourself. After addition comes subtraction, borrowing, 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 all kinds of things. We can borrow a 10. We don't borrow 10s, right? If I'm doing this, this would be a little ridiculous, maybe primary-ish. Let's say I'm going to do 3/4, pretty easy. And I get my common denominator, and I do 2/4 and 3/4, and I do this. That's what I mean by borrowing a 10. We don't borrow 10s, do we? What do we borrow? We have to borrow in terms of the fraction. Borrowing causes a lot of problems. Lazy students will borrow 10. Okay? That can't possibly be correct. We borrow 10s in place value. Another thing that we'll do is we'll only use the borrowed number. We'll only use the borrowed number. Same simple example. Sometimes we'll just borrow the 4/4 and we'll subtract from the 4, not from the 6. We have to remember to add what we borrowed to what we already had, and we'll eventually use 6 minus 3, correct? So that's another mistake with borrowing. Another mistake, forgetting to take it from the whole number. We'll just throw the 4/4 in there. So we have to actually borrow it. We have to take 1 and turn it put it in terms of the denominator, 4/4. It's a kind of a multi-step problem. Remember what are problem areas? Problem areas can be two areas being confused, but it can also just be multi-step problem. Fraction borrowing is multi-step. We have to borrow from the whole number and remember to actually borrow it and take it. We have to borrow in terms of the common denominator. Then we have to add what we borrowed to what we already have. This is a problem area because it's multi-stepped, not because it's especially difficult, which I don't think it is. All right? But it makes sense that we have to borrow in terms of the common denominator. We can't just borrow 10. This is not a decimal place or a place value in front of the decimal. So we have to We don't borrow 10. We have to, we can't just use what we borrowed. We have to add what we borrowed to what we already have. We have to actually borrow from the whole number. And then we have to do what? We can't bring down subtrahends. So another problem area is bringing down the subtrahend instead of borrowing. Bringing down the subtrahend instead of borrowing. We take a simpler problem here and we say 4 minus 2 7/8 does not equal 2 7/8, does it? Very tempting to just bring this down, especially to a student that's in a hurry and just wants to get their homework done. Happens over and over again. And some people just don't catch it. So it has to be addressed, and it has to be, you have to plan to cover it and explain it. And you have to use the proper terminology all the time. So when I say don't bring down the subtrahend, they have to know what I mean by that. Okay? So we are going to identify problem areas, plan teaching strategies to overcome them, and then practice them. We don't do it one time. We practice them all the time. Things that they're having trouble with, we keep coming back and trying to fix it. We're going to fix it. All right, so borrowing is a big area. Of course, common denominator. Those are two major areas of fraction arithmetic, aren't they? And they must be, they're going to be taught in 4th grade, but they must be addressed and retaught in 5th grade, and retaught in 6th grade, and then solidified in junior high. So, borrowing, lots of problems with borrowing. All right, do we have a lot of problem with multiplication? Not so much. Students like, if they're in the fraction section, they like the multiplication the best. They don't have to get the common denominator. They can cross cancel, but you do have to be careful with the multiplication. I'm not saying there's no problems areas with it. I'm saying they're fewer and far between, so I'm not going to put it on our list. Okay? So many times students will not reduce, even though you've taught it to them. They don't recognize it. Many students will have trouble with the common denominator, especially when we get out of our easy multiplication tables. Many students will have trouble with, a lot more students will have trouble with borrowing. Or you'll have 6th graders who've been taught how to borrow in 4th grade forget and do dumb things like not actually take it from the whole number, and a lot of students will do the last one, bringing down the subtrahend. Okay? Sometimes it's not a good idea to do your homework on autopilot. Okay? So we've got, when we have to be able to reduce and recognize things. So these are problem areas. I'm not giving you a list of things you're going to be teaching. I'm giving you a list of very commonly encountered problem areas. So here's where we're going to put the least common multiple versus greatest common factor dilemma. You'll notice that last semester when we went through the fraction math, I did not cover this. You'll notice I did not assign 2.1. They have 2.1 first. All right, it's very difficult for students to remember and keep the two apart. So what we do is we teach them when we're using them instead of out here in some abstract manner. So least common multiple and greatest common factor are an example of a problem area that's not multi-step necessarily and not a lot of different numbers and different things to do. This is an example of a confused problem area. We used to have you take a math placement test as elementary students. Stopped doing that a couple years ago, but that math placement test was eye-opening. Guess what I saw on that math placement test? Constantly. And one of the problems that was missed the most by incoming college students And granted, they haven't had arithmetic for a while. Some people haven't had arithmetic for a long while. The most commonly missed problems involved fractions, and it involved this part here, bringing down the subtrahend here, and not being able to find the common denominator when the numbers were bigger. These were the main ones, and some of this. So this is true whether we're talking about sixth graders, junior high students, high school students, and college students, because these are problem areas that involve bigger numbers, right? Problem areas that involve multi-steps, and problem areas that can be two similar ideas that can be easily confused. So when we are dealing with a problem area, you have to identify it. Maybe we should add to this. Identify and expect. They're going to happen, and it's the same problems year after year after year. We have to identify them and expect them. Then you've got to plan. You have to have a plan of attack. You have to figure out a way that you can get rid of the confusion or go back to the concept, would be what you would do here. You have to show them with the borrowing, why are we borrowing for force and not, why are we borrowing for force and not just doing our usual borrowing? Usually when we have a 2, we just put a 1 in front of it and take it from the place over. Why are we borrowing for force and not just putting a 1 in front of that 2? Why are we doing it? And then why are we using 6 and not 4? Because we had to, we're borrowing for more. And we have to solidify the idea that we are borrowing 1 from the whole number. So this is an important concept, the fact that 4 over 4 is 1. And if we're doing fraction math, we can only add like denominators. So we have to put it in force, even if it's a whole number. Everything is done in arithmetic fractions. Everything is done in the common denominator. Not everything, addition and subtraction. All right, so we have to plan. We have to go back to the concept and explain why, show them why, and try to make a connection. And then we're going to practice it. Okay? We're going to practice it. We're not going to just hope it's not on the test in the curriculum and that 3 or 4 of your students miss it. Okay, so we're going to identify and expect. We're going to plan. We have to go back and reach their understanding. They have to see what they're really doing. They can't approach it as, I have to follow these 4 steps. They have to see what's really going on and why they're borrowing for force and why they have to remember. I just said the word. That's kind of, we should make that something that word taboo in this class. Remember. Is that how we do math? Remembering how to do steps, remembering sequences, remembering. We don't do math by remembering. We do math and master mathematics by what? Understanding. Success is understanding. Okay? And so when we have a problem area, we have a failure in understanding. So we have to plan somehow to go back and get through to their understanding. And then practice it. All right? Then they will be more familiar and comfortable with it. We want them to understand it, and we want them to become familiar and comfortable with something that they always in prior years had problems with. So problem areas are important. So the main problem area that we are going to deal with intermediate fractions and with college students doing fraction math is least common multiple versus greatest common factor. Now we've already identified it, and you need to expect it. Students will always mix these 2 up. So let's figure out why does everybody just about mix the 2 up. And it goes back to a failure in step 1. They are not familiar enough with the root word, and because they're not familiar enough with the root word, they get hung up on the first adjective. That's why many times I will, when I'm dealing with least common denominator, I can sometimes just say common denominator and I get rid of that least. Out of this entire name, least common multiple, least is the least important. Can I still do an addition problem accurately if my common denominator is too big? Let's say the common denominator should be 72, but I use 144. Can I still get the problem correct? Yes. Now I'm going to have bigger numbers, and I'm also going to have a reducing at the end. But I might have reducing at the end anyway. So the least aspect is actually the least important. As long as the denominator is common, it will work. Now we don't want to be using the biggest number. We don't want to always be using the product. But if we understand multiple, we're not going to skip our problem. We could still do it with the product. I don't think I'd want to do 36 times 8, but I could still do it. I could still use the product. But the problem is we've had a failure in understanding terminology, and it's not because I didn't teach them what multiple was, and I didn't teach them what a factor was. What happens is I didn't use. Well, hopefully you taught them the terminology, but I didn't use it. Instead of saying, what is a factor of 24, I would say, what goes into 24? Well, let's stop that question and let's phrase it using terminology. Remember first semester, I told you this has to be deliberate. None of us, myself included, are going to say, what is a factor of 24? We're going to say, what numbers go into 24? Why? It's a failure of terminology. So because I don't use factor and multiple when I'm teaching other things, students do not really know what they mean. So when we are dealing with this problem area, let's figure out where it came from and let's correct it. And then we can also, that will help us in our planning of what to do about it. All right. I said it was a failure of using the terminology. I need to, every time I go over reducing, I need to say, find the greatest common factor and divide by it, or divide by the greatest common factor. Instead of me relying on simple words like just saying cancel the 2. I need to say 2 is the greatest common factor, so when I need to reduce my simple 10/12, I don't just say, reduce that. I'm going to say, what's the greatest common factor? And everybody's going to say, you with me? What's the greatest common factor? Between 10 and 12? 2. I'm not going to say divide the numerator and denominator by 2. I'm going to say divide the numerator and denominator by the greatest common factor. And I'm going to ask, what is the greatest common factor? The answer is 2. So how do I reduce? I find the greatest common factor and I divide the numerator and denominator by the greatest common factor. I keep using the terminology so they're comfortable with it. Because then when we start working with upper level fraction math, these two are going to be together in an assignment. And students are going to inadvertently get hung up on the adjective, and they're going to say, if I have 16 and 18, and I ask you, what's the least common multiple? Let me say I ask my 7th graders. All right, this year there's only 8 of them. 4, maybe 5 out of the 8 are going to say 2. Why? Well, the least common multiple between 18 and 36, 16 and 18 is what? Remember, 16, we have 4 2s. 18, we have 2 2s, and, or no, 1 2, and a 9. So the greatest common factor is only 2. What's the least common multiple? 72. There's no way 72 could be a least common multiple in their minds. Why? There's really nothing least about 72, is there? So when we're dealing with numbers like this, the least common multiple is going to be, there's my greatest common factor, so my least common multiple is 16 times, wait a second, 16 times 9, which is what? 144. Sorry, did that too quickly. 16, or 18 rather, does not go into 72. Why doesn't 18 go into 72? Oh, wait a minute. We don't have enough 2's. So my least common multiple is 8, or 16 rather, times 9. Okay? Because my greatest common factor is only this overlapping 2. So here's 16. Here is 18. There's my greatest common factor. Intuitively speaking, how in the world can 2 be great? Show you this part. Is 8/9 in lowest terms? So what's my greatest common factor? 2. So my least common multiple has to be 16 times 9, which is 144. Okay? Sorry, I was thinking 8 times 9, lost a 2. So do you see the dilemma here? The dilemma here is that least intuitively can't be 144, can it? And greatest just can't be a 2, but in this case it is. The least common multiple is 144. The greatest common factor is 2. So we're always going to be confusing the 2. So the main plan in my plan of attack, how do I fix this, is I have to give them a way to tell the difference. Because when they look at the words, they're going to see the greatest, and it's just going to throw their mind off. You see why it's a problem? 2 can't be the greatest common factor. 2 is a very small number. 144 can't be least. So we got to kind of downplay the adjective. Of course, we need common because it has to be common to both. But we have to really stress and upbeat the noun. Multiple versus factor. And one of the best ways to do that is, yes, we have to be able to tell the difference, so we have to work on our terminology. Then I'll say 18 times 18 goes into 2. Of course it doesn't. All right, so I have to get multiple versus factor straight. And then the best way of all is to give them a tether. I have to firmly tether, we'll put a chain here, this to denominator. Least common multiple is what I use when I'm trying to find my least common denominator. And then I got to tether this, I'm going to tether it away from it, to reducing. So often when I ask what is the greatest common factor between 12 and 18, I might remind them, what would you use? This could be a check. To check if it's greatest common factor, if it works for reducing, it is the greatest common factor. So I'm going to tether it to its application. Okay, they know they would use 2 to reduce. And they also know that they wouldn't use 2 for a common denominator. Now would they? Okay, so fraction math is a huge part of intermediate, I took an extra day on it. Why? Because like I said, every time I'd give that math placement test, did I have people missing the decimal addition? The decimal subtraction? Oh, sometimes I would throw them off with the borrowing. But, so one of the most important things that you can do at intermediate level is get those 6th graders, those 7th graders, even the 5th graders, to get their fraction math down pat, to get those fraction master skills solidified. Okay, so we have to spend time on the problem areas with the fraction math, particularly in 6th grade, 7th grade, 8th grade. In 5th grade, you're going to be reteaching it completely. Okay? All right, so we will buzz by the decimal math a little bit on Friday.